Hey people, and welcome to the financial math section of the grade 12 paper 1 May-June 2026 exam. We are on question 6, and question 6 says 6.1. On the 1st of January 2025, the balance in Ben's savings account was 75,000 Rand. Okay, so 75,000 Rand is how much he had. This savings account earns interest at R% per annum, compounded half yearly. Calculate the value of R if Ben will have 85,000 Rand in the account on the 1st of January 2027. Okay, so all that is happening is Ben has on the 1st of January, 2025, the amount in his account is 75,000. And then interest is attached to this and it is compounded half yearly. And then he ends up with on the 1st of January 2027, which you can see is exactly 2 years later, he ends up with 85,000 Rand. And so we have to find out at what interest rate would this money have grown to this amount in this account. So this is just a case of compound interest growth, which we know the formula is A is equal to P, and then open bracket 1 plus I raised to the power of N. So remember your accumulated amount, the amount that the money ends up growing to is the 85,000 Rand. So we know that one. That one's 85,000. And then the principal amount is the amount that you start with. We started with 75,000, so that is that. And then our interest, we don't know what that is right now. We're just going to go with R. But the thing is, it's compounded half yearly. So you need to take that interest and still divide it by what a half year would look like. A full year is made up of 12 months, and then half yearly is 6 months each. But the thing about it is, this account in a year is going to gain interest twice. So after half a year, it gains interest. And then after half a year, it gains interest. So you need to divide it by 2. And then how long was it invested for? Well, it's from 2025 to 2027. So N would be equal to 2. But then remember, this is compounded half yearly. It needs to gain interest every half year. So we multiply by 2. So we know it's going to gain interest 4 times. And now we can just go ahead and put this in. So A is equal to, and we know this is 85,000 is equal to P is 75,000. Then we have 1 plus, and our interest is I, or I'll just call it R because that's what they called it. So R over 2, and then raised to the power of 4. And all we are doing here is solving for R. So it's not a case where we have to solve for the exponent. It's just R. So what is the first thing that is in the way when you want to get to R? That would be the 75,000, So we need to get rid of this. And since it's multiplying to everything here, you're going to divide to get rid of it. So you divide, but this is an equation. So what you do on one side, you must do on the other side. And so we have, now over here, you can just see it as the 3 zeros would cancel. So just find out what 85 over 75 is. And that is 17 over 15. So that's 17 over 15 is equal to, these are gone, now they cancel. And we have 1 plus R over 2, all raised to the power of 4. So now what is the next thing stopping you from getting to the R? That would be the 4. So this 4 over here, that is the next thing. And so to get rid of that to the power of 4, you'd simply find the 4th root. So we say the 4th root of both hand sides of the equation. We're working with interest, so you do not have to consider the negative solution here. And so I will leave this like this, just so that we don't have to, round off or anything. So I'll leave that. But then what happens here is that breaks that open, because they are the inverse of each other. So it's equal to 1 plus, and we have R over 2. And now how do we get to the R? We need to get rid of the 1. So take the 1 over. So we still have this, But now the 1 comes over to become a minus 1, and then we have R over 2. And so now to solve for R, we need to remove this 2. So it's in the denominator. So it's saying divided by 2. So how'd you get rid of it? You would multiply by 2. So there's a 2, and then it actually has a denominator of 1. So it's going to cancel with this 2 in the denominator. So on both hand sides, we will multiply by 2. Here, there are two terms. I'll just say, multiply by 2. And so what we have now is we have the r is equal to, and we have a 2 multiplied by the fourth root of 17 over 15 minus 1. And now we must just find that. Okay, it's going to be as a decimal, but it's fine. But then we'll go ahead and convert it into a percentage. Okay, and when you press SD, this is what we get. We get 0.06357, not rounding off yet. And then you need to multiply this by 100 so that it is expressed as a rate. Okay, so R is finally equal to, if you take all of that and you just say times 100, you simply get 6 points, and that's going to be 3, and the 7 is going to round the 5 up to a 6. So 36%, and that is our answer. Okay, moving on to the next question. Okay, question 6.2 says, William wants to buy a house. The bank requires William to pay a deposit of 10% of the purchase price of the house. The bank will grant William a loan to cover the outstanding amount subject to the following conditions. Okay, so here there's something that we need to note. The bank is giving William the loan to only cover the outstanding amount. This does not include the 10%, okay, that he has to pay out of pocket. So he has to pay 10%, and then he's only going to take out a loan on the outstanding amount. Okay, and then the conditions of the loan, these are the conditions. We have the loan is to be repaid over 20 years. The interest on the loan is fixed at 11.5% per annum, compounded monthly. An installment of 10,665 Rand is payable at the end of each month after the loan has been granted, starting 1 month after the loan has been granted, which is normal. So the way payments on loans work is you get the loan, okay, it's granted, and then you start paying 1 month after, okay, if it's compounded monthly. Okay, and then they say 6.2.1, we need to calculate the deposit required on the purchase price of the house. So we need to find that deposit that they spoke about, the 10%. Okay, let's just break this down first, because it seemed like, it's just a case where you find the loan amount, the purchase price of the house, and then you say, what is 10% of that? But we need to stop and just think about this quickly, because what they say is that the bank is only giving him a loan on the outstanding amount. Okay, so here is what happens. The house costs a specific amount. So we can look at the house purchase price. And what happens with this purchase price is William is going to pay a deposit. Okay, and we know exactly how much of a percentage he's paying. He's paying 10%. Okay, a 10% deposit. And then he's going to get a loan on the outstanding amount. Okay, so these are things that we really need to just figure out here, because it seemed like, the usual case, but no, there's something we need to think about here. So if the deposit he was paying is 10%, then the outstanding amount would be 90%, of course, of whatever the purchase price of the house was. Now, a simple way to do this, that's if we had this info, is if we had the purchase price of the house, then we could easily just see this and say, oh, it's 10% of that. But we don't. The information they have given us is the loan, okay? And remember that the loan is based on whatever the outstanding amount is, because they only give him a loan on the outstanding amount. So we need to find this. So clearly here, what we need to do is we are going to use this, okay? Because the loan information they gave us is on the outstanding amount. So we're going to use that info to find out what exactly the outstanding amount is, okay? What he takes a loan out on. And then we can use that information to find the purchase price, since we know it serves as 90% of that purchase price. And then, of course, we can use that to find out what the 10% deposit is. Okay, so that's what we're doing. So right now we're trying to find that loan, that outstanding amount. Here is the info we know about it. So you can see that we're working with loans, and whenever we're working with loans and paying back something, okay, where interest is now charged because of what you owe, then we are going to work with present value. So let me put down the present value formula, and let's just find out what all these values are. So our present value, okay, this is going to be that loan amount. We are looking for that final amount. What did he get a loan on? How much was that? So that's what we're looking for. And then the value of X. What is the value of X here? They told us that an installment of 10,666 Rand is going to be paid at the end of each month. That would be your installment. So 10,665 Rand, 65 Rand. Okay. And then the interest is 11.5% and it's compounded monthly. So you can write this as 0.115 and then over 12. And then lastly, we have N. Okay. They told us that the loan will be repaid over 20 years. So that's 20 years, but remember it's compounded monthly. So you need to multiply this by 12. Okay, so this is what we have. Okay, and we can just put that amount. So just tell them 20 times 12, and then that is 240. Okay, and let's put these down. So we're trying to find that outstanding amount. So we'll say this is 10,665, open bracket, 1 minus 1 plus 0.115 over 12, raised to the power of negative 240, and then all over that interest that we have. Okay, so put this on your calculator and then you're going to find that outstanding amount. Okay, so this is the outstanding amount. I mean, it's not the final answer, so I don't think I'm going to round off yet. But it is, that's going to be, okay, so it's 1,065 Rand. And then we have 9,851. Okay, so I'm just not going to round off yet. Okay, so what we have just found now is the outstanding amount. Okay, now that we have the outstanding amount, remember that this stands for 90% of the full purchase price. And we're just looking for the deposit. So let's find out what the full purchase price is. Then we'll know that the deposit is 10% of this. Okay, so here is how we can do this. We're simply just saying that this outstanding amount, it stands as 90% of the total purchase price. I'm trying to find out what that total purchase price is. So I'm going to say this amount, okay, this, and I'll just rewrite it quick. It is equivalent to 90% of the purchase price. So 90% is 90 over 100. Do you see how we put this over the total? Okay, over 100 is the whole that it came from. So this stands for 90%. This is 90% over whatever the purchase price is. And so that's what I'm going to put in the denominator. Okay, so this is an equation we have created to find the purchase price. Okay, so to find the purchase price, you can think about it like this. This is a fraction, okay? This is in the denominator. If it goes to the right-hand side, okay, if we transpose it, it's now going to be in the numerator. And so when we bring it over, it just goes to the numerator. And we're going to leave that 1 million on that side. But then when this stays here, the 1 million, what happens is this is going to come to this side. Okay, so we're transposing it. So whatever is in the numerator is going to go to the denominator, and whatever is in the denominator will go to the numerator. So you're going to take it over, and it's just going to multiply to this. And it's now going to be 100 over 90. And then that will give us our purchase price. Okay, so the purchase price is this. The purchase price is 1,111,184 Rand, and that is 43 cents. I'm going to round off at this point. Okay, so all we just found now is the purchase price. Okay, we have not found the deposit. Now remember that deposit is simply just 10% of this. So now to finally find that deposit, you simply just say, it's whatever this purchase price is, and then times 10%. So take that and say multiply by 10%. Or you can just say 10 over 100 or 0.1 or 0.10. That's still fine. Okay, so it's equal to, I'm just going to take my answer again and just say times 10%, so 0.1. And then there we go. It is 111,000, then 118 Rand, and then 44 cents. And that is our answer. Okay, so that is the answer. That's the deposit. Moving on to the next question. And then question 6.2.2 says, after negotiating with the seller, it was agreed that the purchase price of the house will be 1,100,000. And then William decides to pay a deposit of 120,000 Rand and a monthly installment of 11,000 Rand at the end of each month, starting 1 month after the loan has been granted, which is normal. Okay, so A says, how long in years will it take for him to pay off the loan? Okay, so do you see, again, we're still working with this loan, we're still working with present value, but now they're giving us some updated conditions of the loan. We're not using this amount, okay, we're not using this as the purchase price, we're not using this as the loan amount anymore, we're just using 1,100,000. That's how much they're going to give him. But then he's going to have to pay this deposit, and then he takes out a loan on the remaining part. So we need to find out what the loan amount now is going to be. This is now new info. So the loan amount is going to be 1,100,000 minus 120,000, because this is what he pays as a deposit. This is already paid. Okay, so how much does he need to take out a loan on? And we'll find that first. Okay, and this is 980,000 Rand. That's how much he takes out a loan on. So he takes out this loan, and we need to find out now how long in years will it take him to pay off the loan. So again, we are working with present value, okay, because we need to find out how long it's going to take him to pay off the loan. So with present value, here's our formula again. But let's just discuss, because they do say in years. So let's just talk about that. You see, with your formula, okay, here are certain things we just need to consider. With the n, right, we have negative n there. Whenever they give you the years, okay, like for example, they told us 20 years. Do you see how we took 20 and then we say times 12? So we can kind of just see it like that. When we're trying to find n, you simply just say the years, okay, and then multiply by 12. So in this case, I'm going to take the years, and I'm going to say this is n, and I'm going to multiply by 12 so that I can use that to the power of negative n as 12n, okay? So it will be negative 12n instead. This way, once I finally find out what this is, it's going to be in months, okay? Because once you say I divided by 12, okay, you've already now converted the interest rate to months. So everything is working in months. Okay, interest will only be applied to this account every month. And so the answer that's going to give you here will be in months. Then you'd still need to convert it to years, okay? You know that 12 months make 1 year. And so if you were trying to convert from months to years, you'd finally just divide by 12, okay? For example, 24 months divided by 12 gives you 2 years, okay? So just keep that in mind. We're going to have to do that. And that is why I'm going to call this 12n. Let's keep it as that. Then the loan amount, we already know that amount. That is 980,000. We know how much he needs as his present value amount. That is the loan amount, okay? And then the value for X, they told us that his monthly installment is going to be 11,000 Rand. So this is the new monthly installment. And we just need to put everything in. The interest is still exactly the same. So we'll take that as 11.5%. That is still the same. And then let's just work this out. So 0.115 over 12. Okay, let's substitute. So looking at our formula, we have the present value being 980,000 Rand is equal to, and then 11,000, and then open bracket 1 minus 1 plus interest is 0.115 over 12 raised to the power of, and we have negative 12n. And then all over the interest, so 0.115 over 12. Okay, so we're trying to solve for an exponent here. And so to get to that exponent, what is the first thing we need to do? Well, we can start by getting rid of this number in the denominator, because everything here is being divided by this number. You can simply just multiply both hand sides by this number. Okay, so we'll do that first. And when we do that, these would cancel, and then you just still have this here. So I'm going to multiply this out just to see, does it give us a number that, is easy to work with? Can we actually just use this number? If it gives like a whole lot of long decimals, I would rather take the fraction, okay? The fraction is not bad. We can use that. So we can just say this is 28,175 over 3, and that is fine. And then we still have everything in the numerator. Okay, so once everything is written down, what is the next thing you need to get rid of so that you can get closer to that negative 12n. The next thing would be the 11,000. Okay, we're just trying to get into this, to that. So get rid of the 11,000. It's multiplying to this, so you would simply divide by it. But this is an equation, so what you do on one side, you must do on the other side. So also divide by 11,000 here, and let's see what we get. Okay, on your calculator, you can simply just say divided by 11,000, and then this is what we get. Okay, it's also a fraction. We can use that. So this is 1127 over 1320 is equal to, these are now gone, and then we have 1 minus, and you see that I'm actually going to find the answer of that because I already have this. Okay, it's a fraction. So I'm going to find 1 plus 0.115 over 12. Okay, look at what it gives. It gives 2423 over 2400 raised to the power of negative 12n. Okay, so at this point, do you see that our exponential expression over here, right, the one with the exponent which has a variable, do you see that it's negative? Okay, we have two terms here, 1 and 2, but this is negative, so why don't we just take it over to make it positive? So when you take it over, it now becomes positive. Okay, there's no negative in front of it anymore. But remember, the exponent is not going to change. The exponent is not a normal number. It's just the exponent there. It's not a base. Okay, so we have negative 12n, and then is equal to 1 minus, and then this comes over. That's why it's minus. Okay, so it becomes negative. So negative 1127 over, and I remove something there. Yeah, it was the 0. Okay, so this is why I leave things as fractions, because it's just easier to get back to it if, anything happens. So over, and then we have 1320. Okay, so let's find out what this gives us so we can finally find our answer. So at the end of the day, it's this answer. You're going to say 1 minus that answer that you had. Okay, and then that gives us 193 over 1320. And then we still have this raised to the power of the negative 12n. Now we can finally solve for negative 12n first. So we're going to keep that as a subject using log. Okay, let me just make some space. Okay, so at this point, we're going to make this the subject. So this is now negative 12n is equal to, and we're using log here. So we're going to say log, and our base is whatever number was carrying the exponent, which would be this. So we're going to keep that as the base. And then in brackets, you're just going to put in your number here. Okay, so this is 193 over 1320. Okay, let's find this on our calculator. So on the calculator, we're going to go log and then 2423 over 2400. And then we have 193 over 1320. Okay, so as a decimal, this is what we get. Okay, it's normal that it's negative because this is negative right now. Okay, so it's equal to negative 201.5890. I'm not rounding off yet. Now to finally solve for n, you need to get rid of the negative 12. So we divide both hand sides by negative 12 and n is equal to. So you take this answer and say divided by negative 12. And then that gives you 16.7990. Okay, so at the end of the day, let's just focus on what the question says because always need to check for these ones. They say how long in years will it take him to pay off the loan? Okay, so at 16 years, do you see that he's not going to be done with the loan? Exactly 16. Okay, because there's still this 0.7990 and then that goes. Okay, it may not be a full payment of this amount that he's paying every month. It won't be a full payment of 11,000 Rand that he needs to pay, but there will still be money owed. And so to conclude, we need to say that it's going to take him 17 years, okay? Not just this amount of years. So it's going to take him 17 years to finally complete that loan payment. Okay, so that is it for that question. Moving on to the next question. The last question says, how much will William have paid in total towards the purchase price of the house at the end of 16 years after the loan was granted? Okay, so at the end of 16 years. So they want the total amount that he paid towards the house. They're not saying for the loan alone, okay? The entire amount he paid for the house. So remember that this info was updated. We're now working with he is paying 11,000 every month, okay? And then we also look at the fact that his deposit was 120,000, not, this previous amount that we had. So in total, what he ended up paying towards this house, okay, the total payment, this would be made up of first the total amount he paid for the loan, okay? He paid 11,000 every month, but then they're saying at the end of 16 years. So at the end of 16 years, he would have paid 16 years worth of payments, okay? And then we also need to add the deposit that he made because the deposit was not included in the loan. He paid that out of pocket. Okay, so the loan, how much did he pay in total? He paid 11,000 every month, okay? And they're saying 16 years at the end of 16 years. So this is 11,000 that he paid for 16 years, but he paid it every month. So you need to still say times 12, okay? So 16 years times 12 months. So all of those years he paid that. And then plus the deposit. So the deposit was 120,000 Rand. And then this is the full calculation. If you just go ahead and put that in, you'll get that total amount. Okay, so this ends up being 2,232,000 Rand. That's how much he ended up paying. Okay, so that's how much he ends up paying towards the house. And that is it for the financial math section. And I will see you in calculus.